So in this lecture, we're going to get back to talking about functions. Now, we started this out when the original idea was we were given a set of data and we wanted to visualize that data. We concentrated on ordered pairs in a set, and we represented each of the ordered pairs as a point on a graph. The idea is that we could visualize the data. We extended that idea to include visualizing the solution to equations. So an equation has solutions. It's an ordered pair that makes the equation true. We put all those ordered pairs in a set, and we call that the solution set. And then we can go back and represent that set graphically. The idea is that we can visualize the solution to an equation. We generalized that to a function, so we represented the function as an equation, found its solution set, plotted the ordered pairs in a graph, and that way we could visualize the solution to a function, what a function looked like. The problem with that was for general functions, it's problematic, right? You need infinitely many ordered pairs, for example, to get the full graph. And we saw why that was a problem when we looked at piecewise linear graphs, linear functions. So generally that was a problem. We also looked at a parabola where we didn't plot enough points or the correct points, and we estimated it was a line and it wasn't. So what we did was we've specialized the kinds of functions. It turns out that polynomials can approximate smooth functions. General polynomials are hard to get a handle on. We'll look at that next. So what we did was we specialized. We looked at linear functions, and we saw we only needed 2 points, right? We were given the y-intercept and we had a slope, so it was very easy to graph the solution to a linear function or graph a linear function. And now we're going to look at quadratic functions, and we're going to see that we actually only need 3 points, and we can obtain those 3 points and be on our way. We had a little bit of a divergence. We talked about algebras and what they are, and we looked at algebra functions and algebra involved in complex numbers. Now we'll come back again and do that later with matrices, but I don't know, that was just a I don't know, that was a side trip. I don't know. Anyhow, now we're back on the main theme again, and we're talking about quadratic functions. Okay, so let's go again. The idea is an nth order polynomial. Any smooth function can be approximated by a polynomial. So polynomials are very powerful and very general, and they're a little too much. We'll see in the next sections. We can only do so much with them. We started out looking at the most basic piece, linear, and we found that, again, we could plot that fairly easily, a point and a slope, and they were easy to do. Next up on the food chain is the quadratic, and that's what we're going to be talking about today. So quadratics have this form. And then, of course, there's a general polynomial. So the quadratic just has this form, and instead of calling the coefficients a2, a1, a0, we just call it ax squared plus bx plus c. Again, it's just, So I'm going to call a quadratic function a q for, I don't know, quadratic. And again, the coefficients are a, b, and c in this case. Okay, so, again, that's fine. And we can represent it as an equation, right? In order to graph it, we associate y, the variable y, with the output of the function q of x, and that'll be a quadratic equation. Right? Now, what you get with quadratics, a line is basic enough where you can easily just, do what you want. A quadratic has this unique quadratic factorization. And we're going to see more general cases of this later. So this is just a special case. All quadratic functions can be represented or factored like this. We have to factor out the a first, right? Always keep that in mind. There's always an a. You have to factor this out. And then you can always factor it into these 2 terms. So x1 is a number given by, for the quadratic equation, and only the quadratic equation, given by this formula, the quadratic formula as you'd know it as. And the second one given by this formula, the other piece of the quadratic formula. Now, the general factorization can happen for any polynomial, and we'll see that again in the next section. But okay, for a polynomial, you can explicitly say what x1 and x2 are. So you can always factor it. In general, you can, but for a quadratic, what's unique about it is you can always find this x1 and x2 by this quadratic formula. Notice the only thing that separates the two by the quadratic formula is this plus or minus difference, right? So they're essentially the same computation, but again, it's just a sign involved here. And we'll use this in some examples in a moment. Another piece of terminology is a zero of a quadratic function, or we'll see of a polynomial in general, or a function in general. A zero, okay, we call it a zero, is a number. I notice I use z for, I don't know, I'm thinking zero, z, I mean, what do we want to call it? Z for zero, right? And what it does is, I don't know, makes the function zero. Again, terminology should not be your enemy. I know it's often presented as a way to harass you, memorize all these things. The terminology should help. So when we want a zero, we want where the y value is, I don't know, zero, right? I mean, it should make sense. All right. So find the zeros of a quadratic function in general, right? This is in general. So, okay, let's just look at this. Here's a quadratic function. Now suppose I want this quadratic function to be zero. Right? Zero means it's zero. Now notice what I can do. I can use the quadratic factorization. And again, this is true for more than quadratics. This argument foreshadows what we're going to do in the later sections. So I can always factor a polynomial, but in particular, I can factor a quadratic, right, doing this form. Notice the a comes out in front. Now a is not zero, or wouldn't be a quadratic function. So I'll divide by a, and I just have these two terms, right? So these two terms. So again, there has to be math behind it. Well, here's the algebra rule. If you have 8 times b equals 0, well, I mean, a has to be 0, right? A, that's my a term. Right, that's my a term, and that's my b term here, equals 0. Well, then the a has to be 0, right? I mean, one of these terms has to be 0, right? I mean, it won't work unless one of the terms are 0, and or, right? Possibly both, but at least one of them. Or the other term has to be 0. Again, what I'm trying to emphasize here is there's math behind what we do. We don't do it because I said so, your teacher said so, your tutor says so, your friend says so. That's not how it works. There are rules, and again, most of them are basic rules. Don't be confused by sometimes there's, again, for real numbers, there's a lot of rules. Just the real numbers are really special, but that's aside the point. Most of the rules we do are very basic. So I'll solve the first term, right? And notice what I get. So my x value that makes it 0 is x1, makes the quadratic 0. And another x value that makes the quadratic 0 is x2. Well, the unique thing for the quadratic function is I have a formula for this. I mean, I know I can just compute this x1 for the formula. So notice what the quadratic factorization does is it gives me zeros, and it gives me a formula for computing that. Now hold that thought. That's going to play a big role in what we do for general polynomials next, because we won't have a formula, and that's going to be our problem. Only for quadratics. They're just special. So in fact, in this quadratic factorization, the x1 is in fact a 0, right? And I have a formula for it. And x2 also is a 0, and I have a formula for it. Right? So the x1 and x2 in the quadratic factorization just don't help us factor it, the quadratic, which in fact they do, but they also provide us the zeros. And we have a formula for it. That's what's unique here. That's the big point. I can always calculate points on the graph. We'll see. But that's what I'm going to do, the x1 and x2. So for a line, I have a y-intercept for basically free. For quadratics, I get zeros. I mean, not free, you have to compute it, but I always can get zeros, and there's 2 of them. Okay? So here it is. And how about my third point? It turns out that also I can tell what the extremum is. Now, extremum means we're out there. It's a maximum or minimum is an extreme point. I think I say that in a second. So a quadratic has an extremum. Again, extremum means it's a maximum or minimum value. And it occurs at this point, hk. I don't know why hk keeps coming up at hk. Where h is, well, just given by this formula. I mean, simple enough, right? Negative b over 2a. Notice that's the first part of the quadratic formula, right? And you get the a and b right here from the quadratic function. So I can find the x value, and I get the y value by just plugging into the function. Okay, so I do have the point. So think about it. I have two zeros, and I have an extreme value. That's what I need. And this value is called the vertex of the parabola. Okay? Now notice again, what's going to be different here in general polynomials is we're not going to have this. So as a line is special, so is a quadratic. And then all bets are off. We also have what's called concavity, and that's a shape. So just looking at the leading coefficient, the a value, if that number, again, it can't be 0, it wouldn't be a quadratic, right? It would be linear. If it's a positive number, right, we just get it from the definition of the quadratic. We're concave up. Now, concave up has this shape to it. All right, it's a plus. See how the plus is in the bowl? If we have the plus in the bowl, you're happy. Look at that. Bam, you're happy. I'm feeling it, right? You're happy. That's an easy way to know it. And if the a is negative, right, it's positive or negative. Okay, we just pull it out again of the quadratic function. Or concave down. Concave down is, well, your bowl is upside down, so you're not feeling it. You're sad. Okay, but I mean, anyway, it's a way of remembering. It's a nice check you'll see on your work. Okay, here's an example. Now, here's a typical one of the problems from this section. Solve this. And we saw this kind of issue before when we did the line parallel and perpendicular. Again, you see certain themes come up. Well, what tool do I have available to do this? I don't have much here, right? We're talking about quadratic functions or quadratic equations. And this isn't a quadratic equation at the moment. And notice if I'm looking at it, I see an x squared, which is quadratic. I have the x. So what I'm thinking is it could be put in a form of quadratic. Now this is exactly the problem we had when we did the parallel and perpendicular. Remember they said it's a line and it gave us an equation. But the problem was the equation wasn't in the form of the line. So we had to do some jumping through hoops first. Same here, we have to write this as a quadratic. Once we have it written as a quadratic, we know we can find the zeros, x1 and x2, by using the quadratic formula. That's what we did before. So this is very standard stuff. So now it's a quadratic and you're feeling the love. I get it. I'm feeling the love. And here's my quadratic formula, right? Remember, if I have it in this form, I can factor it, and we have that, right? I mean, we had to do one preliminary step, right? A is 3, B is 2, right? We need these for the quadratic formula, and C is minus 7. Now remember, C is minus 7 here. It's not 7, right? The form is ax squared plus bx plus c. So my c here is minus 7. So be careful. That's a place where people make mistakes, right? Algebraic mistakes, right? It has to be plus minus 7. I emphasized that when we were doing the line, but keep that in mind. So it's minus 7 here. So we have all our data. And notice, given this form, I can factor it, right? I can factor this into, well, 2 terms, right? And what's unique to quadratics is I have a formula for how to calculate this x1 and x2, right? That's what's unique here. So here's my formula for x1, and I'm just going to substitute in the data, a, the b, and the c, right? Put in the data into the formula. And, it's just a number, and I have a formula for x2, same thing, right, x2. And again, that's what you need to the quadratic that you don't get for anything else. And I just plug the data in again. Notice it's exactly the same except for the sign the in front of the square root, right? It's exactly the same. So I just computed it. It just comes out to this. And again, notice your first term is exactly the same. Notice that's the minus b over 2a term that comes out in the vertex. So notice we have this center term, and then we're going to just go to the left and to the right. Right? They're exactly the same. I mean, it's a good way to check. If you do calculations and it's not, you made a mistake, right? So they're exactly the same for the sign. Now, I mean, I got some decimal values out of this. It's fine, you know. I mean, you could carry it off to 50 decimals if you want. Who cares? It's close enough. We're not doing rocket science here, right? I mean, don't knock yourself out by carrying out things to 15 decimal places. That's just fine. Don't have to go crazy here. So now I have the x1 and x2 values. Okay, and I know these solve the equation because we looked at in the previous example, x1 and x2 were zeros, right? And that was the idea. So they solve the equation. All right. Now let's go to the next case. Graph the quadratic. Okay, so let's just go through this again, and then we'll come up with the short form of this. Here's my function, right? You don't have to, again, write this down, but I want you to be aware of this. When we're going to do logarithms and stuff later, this can play out. So just be aware this step exists. I have no problems here. It's defined for all the real numbers. There's nothing going on here, right? I have a set, and I have the rule, right? It's fine. Now, the question here was what we did with linear. You should look at the rule, and I like this as the preliminary step. Is this a special case? I mean, do I just do this by plotting points, or is this a special case? So look at your function. In the previous a couple of lectures ago, we looked and we saw it was linear, right? And we knew if it was linear, we could just plot the y-intercept and use the slope to obtain a second point, and we would draw the line, and we were done. What kind of function is this? Now, again, on the exam, I don't tell you. You have to figure it out. This is a quadratic. Right, notice the coefficients. Notice I had to put in the 0 for b, right? I mean, we played around with that earlier. We had to put it in the right template, so I had to add that x term. So this is, in fact, a quadratic function. And that's good because, you know if I have to, I can use the quadratic formula to compute x1 and x2. So I have a is 0. Notice I have to put this in the correct form. A is 0. I'm sorry. A is 1. Right? A is 1. I was looking at the next term, b is 0. We had to add that to put it in the right template. And that's important. Right? So I had to add the 0 term, b is 0, to fit it in the template. And we played around with that earlier. And c is minus 4. Right? Again, here, plus, I put the plus in, so it's minus 4. So it's obvious there. And that's the idea. We have the coefficients, so I know I have a quadratic. Right? I know I have a quadratic, and I have the data. And if I need to use the quadratic formula, I have the data. Okay, so we're going to follow the same steps here. Right? We're going to follow the same steps here, and I get an equation. So I represent the function as an equation, as a quadratic equation. And I knew the solution set, and then again, the idea is what data should I plot? Now, I'm doing this naively first. We're going to come and do it better. But the idea is, okay, maybe I'll just take some x values, and this is not a good way to do it. We'll shorten this. And again, that's not ideal here. We can specialize. We have a quadratic. So all I need is 3 points, right? 3 points is enough for a quadratic. For a line, it was 2. For a quadratic, it's 3. Now, the question, of course, is, which 3 do we want? And I've already alluded to those. Zeros. Zeros will give us 2 points, right? Zeros will give us 2 points. So what's a 0? A 0 means, I don't know. What does a 0 mean? I'm looking at the picture there. It means y is 0, right? It means the value of the function is 0. So I want to know what x values make that 0. Now I want you to understand, we can always factor a quadratic using the quadratic formula. right? We can always do this. So again, we have the data, right? We have the data. If we can calculate x1, we have the data, we can calculate x2. So we can always do this. Now again, think of things as pro or con. What's the pro of this? The pro is you can always use the formula. The con is it is a cumbersome formula, right? I mean, I know it's in my pocket. I know it's there if I need it. If you're taking a test and you're nervous, use the formula. It's fine. But just look at this. Can you factor it? If you can just factor it, just factor it. For me personally, my advice to you is if I can look at it and factor it in 10 seconds or 15 seconds without working too hard, I'll just factor it. If I look at it and it's going to be a struggle or I don't feel like thinking too hard, then okay, use the formula. But my feeling is the formula is cumbersome. It takes a lot of time and you have to worry about algebra mistakes and stuff. If you just can factor it, just factor it. But don't waste too much time. Give yourself. If you look at it, you can do it, do it. If not, just jump right into the formula. It's the same thing. So if I use the formula, x1 in this case would be -2 and x2 would be 2. You get exactly the same result. Now how do I solve that? Well, there it is. Light bulb, right? A times B equals 0, A is 0, and or B is 0. This comes up, you see the same basic algebra rules come up all the time. Everything is constructed for this foundation. All the other ones are fluff. I mean, I'm not saying they don't come up, but they're very specialized ideas. You have your basics. A times B is 0, A is 0, B is 0. A divided by B is 0 when A is 0. A divided by B is undefined when B is 0. I mean, these come up all the time. And so we're going to use this. There's my A, right? There's my B. And there it is. And it's going to be equal to 0. So I have to have A is 0. Right? There's my A is 0. B is 0. And there you go, you just solve it. And that's my x1 and x2. Right, that's my x1 and my x2 right there. And if I use the quadratic formula, that's what I would get. That would be my x2, and right, so that gives me my x value down here. I don't need to go back to solution set, but I just want to emphasize this. And this is my second value here. So these are the points I'm picking. Notice I'm not randomly picking points. When we did the line, notice we didn't randomly pick points. When we did the line, we took the y-intercept, and then we used the slope to get a second point. We didn't randomly pick. Here, the zeros are giving me these 2 points, right? Now, what's the y value? Right? Again, this would be easy to do. You're working too hard, right, if you're doing much. This just comes out. Well, remember, we get y from this formula, which you could compute it, but it's 0. We constructed this x1 and x2 are zeros. I mean, you don't even have to think. Those are zeros, right? This is how we constructed x1 and x2. This is where we got -2 and 2. They made the function 0. They made y 0. Same here. You don't need the formula to do this. I mean, in future, you don't need the formula. You know if you get x1 and x2, the y value is 0. So that wastes too much time. The point is I have 2 points in the set. 2. I've already got 2. Where do I get the third one? What point did we talk about? What point? Vertex. Right? The vertex is the maximum or minimum. So, here's my theorem. Quadratic function has an extreme value at this point. So it tells us how to compute the h, and then we just plug in and get the k. Right, we just plug in. Now h, notice that's the first part of the quadratic formula, negative b over 2a. Just plug in your data. B is 0. Right? A is 1. I don't really need it. It's 0. Everything is 0. So h is 0. So notice that gives me the x value. How do I get the y value? I just plug in. I just plug into the formula. And there you have it. That gives me my third point. That's all I need. I only need 3 points for a quadratic. So for a quadratic function, I have zeros and I have the vertex. And the concavity check is good because if you made it, there's a couple ways you can check your work. As I said, there's a lot of ways you can check your work. Concavity is very easy to check, so it's nice to know where they messed up a sign because it happens. So if A is positive, right, A is 1 in this case, we're concave up. So we look like that, right? So if you made an algebra mistake, somewhere made a sign mistake, you'd get the wrong answer. So we're happy there. We're feeling it. So I just have the data on the left. All I need is the solution set, right? And the concavity is my check. So here's my graph. Now how did I do it? Notice, here's one of my zeros. I plot that one, right? That's one of the points I have. Here's my vertex down here. I plot that one. And here's my other zero over here. And there it is, connect to 3. And you got it. You just need 3 points. You just need 3 points. Okay? That's the important thing. So notice, what I'm trying to point out here is look at your graph. Notice the distance from the 0 to the center, to where the vertex is, right? It's not the y-axis, it's the line where the vertex is. Look, this distance is exactly the same as that distance. Do you see? That's a check. This distance, right, this distance is the same as the distance. And it's not the y-axis, it's to the line where the vertex is. So the vertex has to occur in the middle. So if you make an algebra mistake, this is one way you can check. And the second thing you want to check is the concavity, right? Because you can make a mistake with the sign of the vertex. So it has to have this shape. Notice it has this shape, right? And that checks out, right? It has to have this shape. So there are two checks that you can make sure if you made a small algebra mistake. Again, you want to safeguard against Lou dropping those point or two on each problem. You can check your work. Right? Notice, this is one thing that again, I want to emphasize this. When we calculated the zeros, this is how we did it, right? And it's not a complicated process. This is correct math, right? So we had A times B equals 0, and this is what we did. This is how we did it in the problem. And this is what a lot of people do, and it's not math. I mean, it's just not math. If you go to a tutor and they do this, I say this all the time, students, when you go to the math center, or you have a tutor, and they do this, you ask, I mean, watch. So you put the 4 on the other side, right? You take square roots, and you say that's the answer, and that doesn't make any sense. I mean, it's not math. You got the correct answer, but it's not math. I mean, it doesn't make any sense. How can the square root, well, the square root is a function. It can only have one value. How in the world is the square root of 4 plus or minus 2? I mean, it's not. The square root is a function. I mean, Google it. Google square root function. I think the first thing that comes up on the page is this, right? A function has one value. One value. And this is why I think you get confused. Sometimes the square root of 4 is 2. Sometimes it's plus or minus 2. Sometimes it's minus 2. Who knows? You stand on your left foot, face to east, and pray to your God. That's not math. That's nonsense. That's why you're insecure. That's why people hate math. If you see anyone do this, ask them how. Say, isn't the square root a function? Yes. Well, then how can it have 2 values? I don't know. I mean, and you're taking math advice from a person like this. Get up and walk away, right? I mean, you just Google it. So, I mean, this doesn't make any sense at all. I mean, it's easy. It looks like math. Is it easier than what we did above? And what we did above is correct. Right? A times B is 0, A is 0, B is 0. How is that harder? Right? I mean, you should be mad when people give you advice like this. It's a function. It is a function, right? It can have only one value. So look, here's my function, right? That's my function. If you plug in 2, right? Plug in 2, it comes up to be 2. Right? You can't get the negative. Plug in the negative 2. And what happens? It comes up 2 also. You can't get the output of the function is a negative 2. It doesn't work. It's a function. It can only have one value. So again, I don't know. It's just the kind of thing that frustrates you. So I'm trying to emphasize the math in this course. I'm not going crazy making you memorize every kind of formula. The A times B equals 0 is correct. It always works. It's always correct. It's actual math. This square root of 4 is plus or minus 2. That's mysticism, right? Why do you hate? Why do you get confused? Why are you insecure? I think these are the reasons. All right, so try to do things right. I'm trying to emphasize, trying to limit the amount of verbiage and signage and everything. I just want to keep it simple. Learn how to do it correctly. All right, now here's a more complicated one. Graph this. All right, well, let's go do, let's do the simple. Okay, the function again, I'm not saying you write it down, but I have no problems. Really what I want you to see in this one is that this is a quadratic. That's really what I'm emphasizing. Again, you should have a defined way of approaching problems. Earlier we looked at linear. You would look at it and you say, this is a line, I need the y-intercept and the second point that I obtained from using the slope. Here you say, it's a quadratic function, right? It's a quadratic function. So what do I need? I need 2 zeros and a vertex. Right, here's my data in case I need it. Right, in case I need it, there's my data. Again, notice C is minus 8. Represented as an equation. I need my solution set. I'm going to use zeros. Right, so really this is the idea. You need the zeros. 0 is where the value of the function is 0, or an equation where y is 0. Now again, you could use the quadratic formula. I think it's a lot of work. If you can look at that, I have a typo here, right? This equation is not, I just took this from the last one, right? Your equation isn't x squared minus 4 here, right? Your equation should be x squared plus 7x minus 8 in that line. That's a typo. Okay, I'm sorry about it, but that's a typo. So see, because it wouldn't factor like this, right? You see, where does this line come from? Well, the line above should be x squared plus 7x minus 8. So I'm sorry about that. It's a typo. And the real one factors is x minus 1x plus 8. Right? So again, a times b is 0, a is 0, b is 0. X equals 1, x equals minus 8. Right? So there you go. That gives me my 2x values. Now we know the y values are 0. How about my vertex? H equals negative b over 2a. I have that data. I plug in my b, right? I plug in my a. I have that, right? And it's minus 7 halves, which is minus 3 1/2. I don't, minus 7 1/2, whatever you're happy with, either way. And then I'm going to do my concavity check. A is 1, so it's positive, so it's going to be like that. All right? Now I'm going to, let me get my data. If x is minus 8, I know y is 0. I don't have to do anything fancy. If x is 1, y is 0, right? I know that. Right? Y equals f of x. And notice h is minus 3 halves. Notice it's a check. Again, h has to be exactly in the middle, right? And I'll calculate the y value from here, from the formula, and there it is. So I have all my data. Okay, so I just summarized. I have my solution set on the left, and it's just 3 points. It's just 3 points. And I have my concavity as a check. Now my graph, here it is. Notice, here's one of my zeros over there. Here's my other 0 over here. My vertex, notice, is in the middle. It's exactly halfway between the 2 zeros. That's the key. It's halfway, right? It's halfway. That's a check, right? That's a check. I'm right in the middle. If I made an algebra mistake, it wouldn't be, right? If I made an algebra mistake, it wouldn't be in the middle. So that's a good check, right? Like if I said it was 3 1/2 at the vertex instead of minus 3 1/2, it's an algebra mistake, right? Halfway. And notice my concavity, it has the right shape. So if I had said that it was 20 1/4 instead of minus 20 1/4, I'd have it upside down. Okay? So again, there's lots of ways to check your work, and that's important, right? When you do these problems, you should be aware of how to check it and what you're doing. So for this section, what's the key idea here? Right? You should be able to find the solution. If you can put the equation in a form of a quadratic equation equals 0, you should be able to solve it, right? That's the key. So you should be able to solve an equation if you can write it down as a quadratic equation, like the first example we did there. Okay? And you should be able to graph a quadratic function by only the zeros and the vertex. That's it, right? You shouldn't have to go plotting all sorts of points and plotting 10 of them. It should be very efficient. Find the zero, find the vertex, put those on the graph, and you're done. Okay, guys, well, that's all we have for today, so good luck.